Okay, it's the time to start our IABSE webinar. Dear all participants and the distinguished speakers and ladies and gentlemen, good morning, good afternoon, and good evening. This is the IABSE webinar. This webinar organized by Chinese National Group and also the e-learning board. My name is Li Mingsun from Chinese National Group of IABSE. It's my honor to chair today's webinar. We have a speaker, Mr. Huan Yongchen from China. So today's topics of his speech is challenges and innovations in the Shenzhong Zhongshan link in China. So before start his lecture, I would like to give a brief introduction about our speaker. So Mr. Chen is the Deputy Director of the Chief Engineer's Office of the Shenzhong Zhuhai Link Administration of China. And he's first class registered structural engineer in China. And also he's a professor of engineering, served as off-campus supervisors for the graduate students of South China University of Technology in China. And after graduating with master degrees, and he has worked for 22 years, including 10 years in design and 12 years in technical management for large infrastructure projects such as the Shenzhong Zhuhai, Shenzhong Zhongshan link. And he has published more than 40 papers and 3 books, and obtained many patents, and also participated in the code writing and so on. And Shenzhen and Zhongshan is the 2 big cities beside the Zhuhai Bay in Guangdong province of China. So this project linked 2 big cities with bridges and tunnels. It's a quite challenging project. And we will have 45 minutes for lectures. And after that, we will have about 15 minutes for Q&A. So all the participants, if you have a question, please use the Q&A sections. You can find the icon under your screen. There's a menu bar for the Zoom, so you can input your question there. And if you have any problems, you can also use the chat box to conduct this. Yeah. So please join me to welcome Mr. Chen to start your lectures. Thank you.
Okay, thank you, moderator. I will share my screen. Can you see my screen?
Did you? Okay, okay, or okay, no problem.
Okay, all good.
Okay, let's begin. Ladies and gentlemen, good afternoon. My name is Huan Yongchen. I come from Shenzhong Link Administration Center of China, which is the owner of the Shenzhong Link. Today, my report title is Challenges and Innovations in the Shenzhong Link. My report concludes 4 parts. Part 1, overview. Part 2, Sea Suspension Bridge. Part 3, Steel Shell Immersed Tube Tunnel. Part 4, Conclusions. Part 1, Overview. Shenzhong Link is situated at the estuary of the Pearl River in South China. It's the geometric center of the Guangdong, Hong Kong, Macau Greater Bay Area, about 31 kilometers from the Hong Kong Zhuhai-Macau Bridge to the south, which is another super project. The Shenzhong Link is a world-class cross-sea cluster project of bridges, islands, tunnels, and undersea interchange, with a total length of 24 kilometers, a design speed of 100 kilometers per hour, a width with 8 lanes, and a cost of 44.69 billion renminbi yuan, about $6.3 billion. From the west to the east, the first main structure is Zhongshan Bridge. It's a cable-stayed bridge with a main span of 580 meters. The second main structure is Shenzhong Bridge. It's a suspension bridge with a main span of 1666 meters. And the third main structure is West Island. It's an artificial island. The fourth structure is Shenzhong Tunnel. It's a steel shell immersed tube tunnel. On the east side, there are East Island and undersea interchange. The fourth key structure is Shenzhong Bridge. The main span is 1666 meters. Currently, the world's largest span offshore suspension bridge. It faced with a series of challenges such as frequent strong typhoons, giant anchorages in the sea, and structural durability of the marine environment. The second structure is East Island and undersea interchange. It's the world's first 8-ramp undersea interchange. The interconnection between the undersea and the in-service bridges. The main challenge is high construction risk of deep foundation pit with deformation less than 5 millimeters and high operational security risk. The third key structure is Shenzhong Tunnel. It's the world's first 8-lane undersea tunnel with features of ultra-wide 46 meters, ultra-long 6.8 kilometers, and deep buried 38 meters. Steel shell concrete immersed tube tunnel is the first application in China with a blank in entire industry chain. After 10 years of research, we have achieved innovations in design theory, materials, processes, and equipment. The upper picture is element of the tunnel, and this is the final joint, just like a big huge jaw. And the below picture shows the longitudinal section of the tunnel. The total length is 6.8 kilometers. Compared with similar cross-sea cluster projects in the world, the Shenzhong Link is faced with the most difficult construction challenges. This project includes Chesapeake project in USA, Horizon Strait project in Europe, Busan project in South Korea, Zhuhai, Hong Kong, Macau Bridge in China. We compared the sea bridge, artificial islands, and undersea tunnel. The Shenzhong link has the world's largest span of shore suspension bridge. There was first 8 ramp undersea interchange, and there was first 8 lane undersea tunnel. World-renowned companies participate in project design, consulting, and construction. There are 8 designers and consultants, including CCCC Highway Consultants Company, Water Transportation Consultants Company, COWAY, China Railway Major Bridge, Regional South, and Design Institute. There are 52 contractors, including 4 CCCC companies, Poly Chongda, CSSC, and 4 China Railway companies. With a 7-year design and 7-year construction period, the Shenzhong link opened to traffic in June 30, 2024. The 3 key control projects of bridge, island, and tunnel are progressing simultaneously, saving more than 1.5 years of construction time compared to similar projects. The 7-year plan and design is from 2010. The construction is finished in 2024. The total is 14 years. During the design phase, we held an international design competition, won first place by the team consisted of COWAY, DW, and SMEDI, and carried out specialized landscape design. Then we carried out preliminary design, including technical design, construction drawing design, and detailed code design, such as the large temporary projects. At the same time, many scientific researches are carried out, including design theory, technical standards. We adopted a uniform geometric shape for bridges, the diamond facet, including all vertical components, such as the main tower, anchor blocks, piers, light poles, and balustrade columns, etc. We use monocolumn piers in approach bridges, which makes the whole alignment harmonious, transparent, and the water resistance ratio is lowest. The appearance of Shenzhong link looks like a kite flying in the sky. At the kite head, the West artificial island not only is symbolic work, concise, vivid, and powerful enough to leave a deep impression, but its shape also has a great deviation effect, which can minimize the water blocking effect. The buildings on the island are built on the basis of meeting traffic conversion, maintenance, and rescue needs. Use beam model assisted design to remove the ventilation tower. This is the ventilation tower from the central public space to the left side, achieving a beautiful composition of upright vertical elements and stretched horizontal elements. For the first time, the West Island has successfully applied 28 meters diameter steel cylinder, on an uneven without rock foundations. The West Island was formatted within just 4.5 months, with minimal impact on surrounding marine life, such as white dolphins. Here are 4 photos of the West Artificial Islands. Number 1 is island wall. Number 2 is sand backfilling. Number 3 is buildings construction on the island. Number 4 is night view. The East Island and the world's first 8 ramp undersea interchange are integrated adjacent to the airport and passing under the existing highway. The functional requirements are high, and the island's construction area needs to be controlled. We adopted the active control measures of steel pipe pile reinforcement, foundation reinforcement, and steel support solver supplement system to meet the strict deformation control requirements. 5 millimeters for the existing highway bridge. The entire construction period has no negative impact on surrounding area. Part 2, Sea Suspension Bridge, that is the Shenzhong Bridge. It's the key engineering of Shenzhong Link. It has 3-span continuous, fully floating suspension bridge with a span arrangement of 580, 1666 meters and a right span ratio 1/9.65. The deck is 91 meters high and tower is 270 meters high. It has steel monobox girder, H-shaped anchorage, and H-shaped tower. The first technical challenge is structural wind resistance and dynamic performance control in area with frequent strong typhoons. The bridge deck is 91 meters high, and the flat test wind speed is 83.7 meters per second, which is the highest in the world. Secondly, is the difficulty in the construction of giant anchorages in the sea, with a soft soil cover level of 40 meters and a large undulation of the rock surface. These are different from the Great Belt Bridge, which is another sea suspension bridge, mainly in the cable force and the geology. The third technical challenge comes from the main tower. The concrete bridge tower reaches a height of 270 meters, and its offshore environment is 10 kilometers and is harsh. Traditional construction techniques cannot meet the requirements of high-quality construction. That is, low construction efficiency. Concrete quality is difficult to control. Long on-site construction time for steel reinforcement. High demand for labor and poor working conditions. The fourth technical challenge is durability guarantee of structures, such as cables, in highly corrosive environments. Number 1, high temperature, high humidity, and high salt marine environments, with prominent corrosion problems. Number 2, excessive traffic volume brings structural fatigue problems. After 1 year of operation, The daily average traffic volume exceeded 90,000 vehicles, with a maximum of 181,600. We achieved four main technical innovations. Number one, wind resistance and structural system technology. Number two, key technologies for the construction of super large anchor foundations. Number three, intelligent construction technologies for the superstructures. Number four is durability guarantee technologies for suspension bridge cables in marine environments. Number one is wind resistance and structural resistance technology. A combined aerodynamic control technology of horizontal guide plate, upper stabilizing plate, high permeability railing for steel monobox girder has been applied, which not only solves the problem of vortex vibration, but also significantly increases the critical throttle wind speed of ultra-long span suspension bridge, with steel monobox stiffened girder to 88 meters per second. And it saves 18% of steel compared to split box, about 12,000 tons. We compared with the split box with the girder height of 5 meters, 4.5 meters, and the monobox is 4 meters. We add a horizontal guide plate and upper stabilizing plate. A new type of wind-resistant balloon with self-resetting function and energy dissipation capability using spring friction damping combination has been developed, achieving elastic close contact between the balloon and the main girder. The peak response of the transverse main girder under earthquake action has been reduced by 42%, from 20 to 12. Key technology for the construction of anchor foundations. We have developed a new structural system of self-balancing flexible steel coupler with composite steel pipe piles and parallel steel well for deep soft foundation, which has better stress resistance, low cost, and more efficiency. We applied a rapid island construction method for large-scale circular coupler with deep soft soil. Only 45 days of coupler closure and 4 months to form the island body. Firstly, the undersea plastic drainage plate construction and the composite steel pipe pile construction and sand bag filling in the island and form the island. Number two, key technologies for the construction of anchor foundations. We have developed an intelligent decision-making system for the digitalization of the entire process of trenching for underground wall construction, which has achieved a verticality deviation of less than 1/800 for the trenching of the underground wall, and a leak-proof excavation of foundation pits. Number three, intelligent construction technology for the superstructures. For the first time, a flexible manufacturing production line for three-dimensional steel mesh and a complete set of construction methods for steel components have been developed, achieving industrial production and assembly of bridge-tall steel components, rapid installation of segments, and a 70% reduction in on-site high-altitude workouts. The left photo is factory manufacturing, the processing, bending, and flip, and on-site assembly process. We have made an intelligent tile maker machine, which integrates automatic concrete distribution and vibration, intelligent cooling, and automatic control. The qualification rate of its concrete cover is over 99%, and current time of segmental concrete exceeded to 14 days, and the efficiency is improved to 1.4 meters per day. This is the tile maker machine. A double-sided submerged arc full penetration welded joint between the U-rib and the deck was developed. This technology reduced the average welded defect size from 300 micrometers to 20 micrometers, decreases the incidence of defects by 60%, and increases fatigue life of this welding structural detail by more than 5 times compared with traditional welding. And the fully automated welded machine was made for the first time, realizing the industrial production of 280,000 tons of steel box coater in the Shenzhong link. The upper picture is single-sided welding, and Shenzhong link we have the double-sided welding. The welding defect size is reduced from 300 to 200. We have developed a marking method installation technology based on high precision benchmark cable strands, which overcomes the impact of marine wind environments. The precision of benchmark cable strands has been improved from 115,000 to 150,000, saving about 20 days of construction time. We have developed synchronization of lifting and welding technology for suspension bridge steel box coater, which has shortened the construction period by another 20 days and avoided the impact of typhoons. This is the high precision benchmark cable strands and anchored on the main cable saddle. Number 4, durability guarantee technologies for suspension bridge cables. By 6 mm, 2060 megapascal zinc aluminum rare earth magnesium alloyed coated cable steel wire and strands were developed and applied. The corrosion resistance of this coating is more than 3 times of hot deep galvanized steel wires and 1.5 times that of the zinc aluminum coating. We have developed a new type of cable clamp integral sealing structure and device, which reduces the risk of the steel wire corrosion caused by air leakage at the joint between the cable clamp and the main cable. This is the sealing details at the end of the cable clamp and the spring-type rubber sealing strip. We have developed an intelligent main cable with embedded sensing fibers and an array-type weak fiber grating humidity sensor, which enables real-time temperature and humidity monitoring of 3,000 meters long main cables. We developed a main cable intelligent dehumidification system with self-sensing and self-regulating function, achieving deep sensing, real-time warning, and active control. Through the above measures, the humidity inside main cables were reduced to below 40% within just 3 months, from June to September. The Shenzhong Bridge has won the Star Prize, Gold Deer Medal of the 2024 China Highway and Transportation Society, which is the highest industry award in China. The Shenzhong Bridge, formerly was Lindian Bridge, wins the George S. Richardson Medal at the 2024 International Bridge Conference, IABSE. Awards Committee comments. During the design and construction of the world's largest offshore suspension bridge, many striking innovations were developed that will benefit the wider bridge engineering world, making Lindian Bridge a worthy recipient of the George S. Richardson Award. Now I'll show you a short video, about 3 minutes.
Shenzhong Lake crosses the estuary of the Pearl River, the third longest in China, and is a cluster project of bridges, islands, tunnels, and undersea interchange. Lindian Bridge, the control engineering, faces world-class challenges, including strong typhoons, deep silt, heavy traffic, strong corrosion, etc. The bridge has set 5 world records. We follow the concepts of safety, applicability, beauty, and durability, and have made innovations in design, construction, and research. Design. The bridge is located in a frequent occurrence area of strong typhoons. Considering the vortex vibration performance and cost, we adopt an integral steel box girder section, which saves 12,000 tons of steel compared with the split section. We developed a comprehensive aerodynamic control measure, includes central stabilization plate, which increased the flutter critical wind speed to 88 meters per second and can withstand Category 17 typhoons. Construction. In order to improve construction efficiency and safety of the main tower, a flexible manufacturing production line for steel bar parts was developed, and an intelligent tower construction machine was used for the first time. The construction speed of tower columns can reach up to 1.2 meters per day, and only 8 workers are needed at heights. In just 1 year, the 270 meters high main tower was built. Research. The main cable is designed to be used for 100 years, which is in an extreme marine corrosive environment. In order to improve the durability, we developed a 2060 megapascal high-strength steel wire with zinc aluminium magnesium coating. The steel consumption is saved by 1,700 tons, compared with 1,960 megapascal wire, and the coating's corrosion resistance performance reached more than 1.5 times that of zinc aluminium coating. The Lindian Bridge not only support the transportation of Guangdong, Hong Kong, Macau Greater Bay Area, but also support the construction technology of larger span cross-strait bridges in the future.
Okay, let's continue. Part 3, steel shell immersed tube tunnel. The main technical challenge is ultra-wide with valuation deep buried. So the reinforced concrete tunnel cannot solve the problems of structural climate control, anti-seepage, and durability. Steel shell immersed tube tunnel, which has high load bearing capacity, good waterproof performance, suitable for factory manufacturing, is the optimal solution. We invented new structures, established new theories and methods for design. We have invented a new structure of steel shell concrete for ultra-wide and deep buried immersed tube tunnels. Established the theory and method of bidirectional strengthening bending resistance and free mechanism shear resistant design. Pioneered the interface anti-slip T-shaped rib shear connection and achieved a breakthrough in the new structural design theory from 0 to 1 for the first time internationally. We have developed a key rational structure for steel shells and established a steel shell concrete composite structural system, ensuring reasonable structural stress and facilitating the concrete inside steel shell to remain intact. Shenzhong link has the bigger compartments, the height of 1.5 meters high. We clarified the closure mechanism of steel shells in marine mud and gravel environments, and developed new high-performance sacrificial anode materials. Established a durability design system of sacrificial anodes, heavy coating, corrosion alarms. Breakthrough the 100-year durability challenge of steel shell in marine mud environments. The accuracy of the bending shear calculation has been improved by 10 to 30%. The bearing capacity of shear connectors has been increased by 25%, and approximately 12,000 tons of steel have been saved. We won the Star Prize Gold Deal Medal of the 2023 China Highway Transportation Society. Number 2, we created a new intelligent construction system. The challenge is the standard tunnel element is 165 meters long, with over 2,000 compartments, 40,000 embedded parts. So we have pioneered the intelligent manufacturing technology system of 4 lines and 1 system for large-scale steel shell tunnels, applied 3-dimensional digital collaborative production design technology, and achieved digital intelligent production. The 4 line is intelligent cutting of steel plate, intelligent welding of small sections, and the large segments intelligent welding. And the fourth is intelligent coating we have innovatively developed the preparation and performance control technology of highly stable self-compacting concrete, developed specialized mixtures, and formed a preparation technology and quality dynamic control method, solving the material stability problem of closed compartment filling under the continuous pouring condition of single tunnel elements of 30,000 cubic meters concrete. This is development of high stability special admixtures. A process where the large-scale tunnel element compartments filled with concrete staggered was applied, and the international first intelligent pouring equipment. This is the pouring equipment and control system for steel shell concrete tunnel elements were developed, creating multiple world records in terms of efficiency, 1 tunnel element per month, and filling density, compactness, 99.95%. The next challenge is traditional. The Gauer method for avoid detection was suitable for steel plate thickness less than 20 millimeters, but Shenzhong tunnel's steel plate thickness reached 40 millimeters. So we have pioneered the millimeter level precise and rapid detection technology of impact image method, neutron method, for the detection of voids in 40 millimeter thick steel plate concrete with world-leading accuracy and efficiency. The empowerment of intelligent structure has significantly improved work efficiency, shortened the construction period by 285 days, and saved about $14.5 million. We won the Star Prize of 2023 award from China Steel Construction Society. Number 3, developing super engineering equipment. The challenge is 80,000 ton elements with an ultra-long floating distance of 50 kilometers and an ultra-long lateral towing distance of 5 kilometers. So, for the first time in the world, an integrated vessel, this is the integrated vessel for tunnel elements sinking transportation and installation has been developed. The floating efficiency has been increased by 4 times, which has significantly reduced the impact of tunnel element floating on navigation in the Pearl River estuary, and solved the problem of long-distance floating transportation of 80,000 ton tunnel elements. We have developed a complete set of technology and construction process of tunnel element sinking and high precision docking in deep water, integrating intelligent construction management system. The installation efficiency has been doubled and 2 world records has been set, i.e., millimeter level accuracy for tunnel elements installation at a depth of 40 meters and installation speed of 2 tunnel elements per month. The next challenge is the Pearl River estuary is heavily silted. So, for the first time, a gravel leveling and drainage integrated ship, this is the ship, has been developed. which integrates functions such as rapid feeding, leveling construction, and precise judging. The efficiency has been developed from 12 days, 15 days to 4 days. We created multiple world records in floating speed, installation speed, and millimeter level judging accuracy, and systematically innovated the construction technology of offshore immersed tube tunnels, and won the star prize from China Water Transportation Construction Association. Number 4, the world's first undersea docking and pushing out final joint. The challenge is large cross-section, shallow and deep channel, and complex ocean currents. So for the first time, our team has ingeniously applied the overall idea of embedding the final connector into a standard tunnel element, like huge jaw for floating, sinking, and pushing out, and have developed the overall structure and key outfitting structures. The next challenge is the total resistance of seawater at the end phase of the final joint, which is 100,000 tons. So we invented a new method of hydraulic balance and jack pushing out, while the jack only needs to provide about 500 tons of the ballast to push out the joint and connect it with controllable accuracy. We developed 11 sets of installation equipment and control system with remote intelligent operation throughout the entire process, ensuring safety, speed, and high precision. We set a world record for the installation of this final joint in 18 hours, achieving millimeter level docking accuracy and providing a new Chinese solution for the closure of offshore immersed tube tunnels, shortening the construction period by more than 3 months, has avoided using of large lifting equipment and excavation of corresponding temporary waterways, saving about $33.8 million, and we won the star prize from the China Society of Navigation. The Shenzhong Tunnel was awarded the title of one of the 50 ITA iconic projects by the International Tunneling and Underground Space Association. Part 4, Conclusions. We have published over 200 papers, over 20 monographs, 20 standards, 200 invention patents, and won over 40 science and technology awards, including 10 Star Prize and George S. Richardson Medal from IABSE, 50 iconic projects from ITA. The Shenzhong link was completed and opened to traffic 6 months ahead of schedule, with an average daily traffic volume of about 90,000 vehicles. The direct economic benefits exceeded to $25.4 million, reducing carbon emissions by 405,000 tons per year. As the iconic structures and hotspots in the Greater Bay Area, the Shenzhong link paints a beautiful picture and harmonious coexistence between engineering, nature, and culture. On the day of completion and opening of the Shenzhong Link, Chinese President Xi Jinping praised it with a congratulatory letter. The Shenzhong Link has overcome multiple world-class technical challenges and created multiple world records. That's all. Thank you very much. I will stop share.
Okay, thank you very much. Maybe you can leave your share. Maybe we'll maybe use PPT for answer the questions.
Okay.
So
okay.
thank you very much, Professor Chen. It's a very nice presentation, very impressive project. There are many challenging technical issues and innovations. And I think we got a couple of questions. Can you read the Q&A box? So can you read the?
Okay.
So we can you read the? There's a Q&A.
Q&A.
问答.
Oh, I know. What's
You
the
can
biggest
click.
feature of the
Yeah.
Shenzhong
The first we have
compared with other foreign
three.
projects?
Yeah. What's the biggest? First question is what's the biggest feature of the Shenzhen China Shenzhong channel compared with the other foreign projects? I think you have one slide to compare them with other projects.
Compared with similar
information. Yeah.
Okay, compared with similar projects, the Shenzhong Link has the world's largest span offshore suspension bridge, 1666 meters, the Shenzhong Bridge. And secondly, it has the first 8 ramp undersea interchange, the East interchange, and the first 8 lane undersea tunnel, the Shenzhong Tunnel, which is a steel shell immersed tube tunnel. So the bridge, island, and tunnel is the most difficult in Shenzhong Link. Okay.
Okay. And let's move to second.
Second is
question. I think for second audience, so there are several questions. One by one, we can answer one by one. The first is, could you please share the current average daily traffic value on the link and how it compared with the initial forecast? I think you have a number.
Okay.
The
average daily traffic volume is exceeded 90,000 per day, and the maximum is 181,600. Compared with the initial forecast, it's doubled.
Oh, double.
Yeah,
so,
double.
It just opened the traffic. Yeah, it's very good. Second, the question is, has your organization or industry experienced noticeable changes in travel time or transportation cost since the link opened? So how about the
travel time from Shenzhen to Zhongshan? Formerly it maybe have 2 hours, and now it only have 20 minutes.
Okay.
Okay.
From 120 minutes to 20 minutes.
20 minutes.
Yeah, about 1.6.
We see.
And how about the cost? Cost.
See the main challenge in main time.
Transportation costs Can you give some
the
idea?
maintenance. The challenge in
The last
maintenance,
question.
I think it's typhoon, fire, and the crash of the ship, and the earthquake is the main challenge in maintaining the tunnel, bridge, and artificial islands.
Also,
Next,
earthquake.
based on the experience, how many years might it take? Each break even and work
Let me read the question first. So next question is based on your experience, how many years might it take for the project on each broken even? And what role will traffic growth play?
The break even maybe 15 years or
Okay.
or 20 years, maybe.
15 to 20 years.
And the role will traffic laws play. Now that the traffic cross the Zhujiang River, it's grows rapidly, and it's from 300,000 to 1,400,000.
Okay, it's
And
quite
I
good.
have no.
By the way, is there a new project is under planning? New link between the two sides of the Zhujiang Bay, maybe upstream or downstream, I'm not sure. There's a new project under planning. 是不是要建一个，还要建一条通道啊？
Maybe the Shenzhou link, Shenzhen Zhuhai, Shenzhou
深圳珠
link
海
is in design, maybe.
Okay.
Shortening, yes. Shenzhou link. And
so the economy at that area is very active. That means okay. Okay. Next question is I think it's also from first audience. Other questions, Professor? The Shenzhong Link is a world-class project that integrates bridge, artificial islands, and immersed tunnels in the cooperative design and construction management of different structure forms, such as suspension bridge and immersed tunnels. What has been the greatest technical challenge? And how do your team achieve the interdisciplinary and cross-domain breakthroughs? What's the biggest
there are many
challenge?
Many technical challenges. For bridge, island, and tunnel. As to the bridge, the Shenzhong Bridge, it has strong typhoons, heavy crossing. So we have many scientific researches to solve the problem. Can I show the PPT now?
Yeah, you can share the screen again.
Okay, I'll share the screen again. Yeah. Firstly, is the structural wind resistance and the dynamic performance control. Secondly, is difficulties in the construction of giant anchorages in the sea with soft soil
Soil.
foundation. Number three is the concrete bridge tower. The traditional construction techniques cannot meet the requirements construction. So we make the tower maker machine. The fourth technical challenge is durability guarantee of structures, especially the cables in the highly corrosive environments. The first is the high temperature, high humidity, and high salt marine, and the excessive traffic volume. This is all the challenge to Shenzhong Bridge.
Okay. The
Okay.
strong typhoon, soft soil condition, high concrete tower,
And
and
high
durability of the
tower.
cable.
Yeah.
Yeah. How about the tunnel?
The tunnel is basically the ultra wide, 46 meters, and with valuation from 46 meters to 70 meters and deep buried in 38 meters buried. So we first application the steel shell immersed tube tunnel in China.
Construction in deep water.
Yeah.
Okay. Thank you. So shall we continue? We have still 5 or 6 questions. The next question is what is the width and the depth of the monostube sectional box girder? The dimension of the box girder. Width and
What is the width near 50 meters. Depth is 4 meters of the
50
steel
50 by 4.
segment box girder.
Yeah. Okay. 50 by 4. Yeah. Okay. And next one. What software was used for structure analysis?
Software, mainly software. There are 3 design companies. They are used different software, such as the IABSE and the software design by themselves, and it made in China. There are many software. Yeah.
Yeah. Okay. It depends on the design company. They use their self develop the software or some commercial one.
In the seismic design.
Yeah. Okay.
This question I'm not familiar.
Okay.
Next
Thank you.
one.
Next one. What is the ship impact protection system for the bridge tower?
The ship I can't see the question. Ship impact.
Ship impact for the bridge tower. 船撞.
The ship.
You have some protection design for the
no
protection system.
Yeah, what's the question?
那个船撞.
In Chinese is 船撞. What means 船撞?
就是那个船撞那个桥墩.
船撞力吗？是力吗？还是荷载吗？
那个防船撞 protection system.
Protection. Yeah. We have the video we have the video set it on the main tower to monitoring the water, the sea, the river.
So
And
that means
radar, and
it's
radar,
like
and radar sensor, the monitoring video and radar sensor to protect the ship crash.
that's a kind of active alarming system. You monitor and check the trace of the ship, and if some ship come to the tower, you will give some the signals to warning the captains of the ship, or do you have a how to say?
The captain,
Passive
the
protection system.
captain, the pure cap.
有那个被动防撞的系统吗？
有，
被动
就是
的保护
围掩，就是 captain around
啊
the pile
，the
cap.
curtain surround
Yeah,
the
yeah,
foundation of
the steel captain around the pile cap.
the pylon. Yeah, okay.
The main tower, we have the active major.
Okay. Thank you. And the next one is how critical.
I can see this question.
I can read for you. How critical is the seismic design for the immersed tunnel? Seismic design for the tunnel.
0.1 G, 0.1 G.
0.1 G, not so large, I think. Yeah.
Yeah, 0.1 G. Yeah.
That's 0.1 G is a ground surface acceleration. 地表的
对，
加速度是吧？
是 grounding 啊。
The earthquakes are not so strong around that area. Yeah, ground surface acceleration is 0.1 G. Okay.
Not so big.
Okay, maybe last question. Last one, concerning the intelligent construction system implemented in the first time on concrete or steel works, is it possible to replicate the future project exactly as it is? Or do you believe some modification are necessary to enhance efficiency? Did you get the
construction system?
About the intelligent construction system?
It's about to implement in the future. Yeah, I think it's possible to copy. And in China, we have many projects have copy all technique to build the steel bridge.
Okay. So similar projects, we can use same technologies. Okay, I think it's a little bit behind the schedule. There so many questions. Thank you very much for your question and answer your discussions.
Thank you, moderator.
Yeah, thank you very much again for your excellent presentation, and it's a very challenging, impressive projects. And thank you for all the participants for your questions and the discussions. So we would like to finish our webinar. Thank you very much, Professor Chen, and for all the participants. Thank you very much.
Thank you.
We would like to finish our webinar. Thank you.